Welcome to a video on prime numbers and prime factorization.
We will start by defining a prime number and making a list of prime and composite numbers. Now, the definition of a prime number is a number that can only be divided evenly by two numbers, known as factors, one in itself. If you try to divide it by any other number, you will end up with a decimal. So let's make a list of a few prime numbers. So for primes, we have the number 2, 3, 5, 7, 11, and I think this will be enough for our small list. So all of these numbers can only be divided evenly by 1 and themselves. For example, let's take the number 5. 5 can be divided by 1, and that gives you a 5. 5 can be divided by 5, and that gives you a 1. But if you divide 5 by any other integer, you will end up with a decimal. That's why 5 is a prime number. Now, you're going to notice that on the list, you don't see the number 6. And the reason why 6 is not there is because 6 is not a prime number. Now, 6 can be divided by 1. That gives you 6. And 6 can be divided by 6. That gives you a 1. However, 6 can also be divided by 2. That gives you a 3. And 6 can also be divided by 3. And that gives you 2. So it has more than two factors. You cannot consider 6 a prime number. Now, these numbers, the ones that are not prime numbers, they're called composite numbers. So let's make a list of composite numbers, a small one. 4 is a composite number. 6, as we just showed, 8, 9, 10, and 12. So composite numbers will have more than two factors, and of course, they're not prime. We will now use prime numbers to find the prime factorization of positive whole numbers, known as integers. We will use the upside down division to help us with this process. So let's bring in the list of the prime numbers, a few of the ones that we wrote on the previous page. So what we're going to do is we're going to divide 1/12 starting with the smallest of the primes. In this case, it's a 2. And we will continue to try to until we can no longer divide evenly. When that happens, then we move to number 3, the next prime number, and so on. So let's start with 1/12. When I divide 1/12 by 2, I get 56. And then I can still divide 56 by 2. And when I do that, I get 28. And then I can divide 28 again by 2. And I get a 14. And then we are able to divide once more that 14 by 2. And we get a 7. Once we get to this result, we're going to stop because if you notice, this 7 is a prime number. So this is when we know that we should stop and we have completed the prime factorization when the result is another prime. What that tells us is that the prime factorization of 1/12 is going to be 2 times 2 times 2 times 2 times 7. And you might be asking, where are you getting these numbers from? We're getting these values that are outside of that division, the ones that are on the left side, and also the final result. That is how we create our prime factorization. Now, while this is not the only way to find the prime factorization, I found that with this method, you don't have to guess the factors, and it guarantees you that you will never miss a number in your answer. Let's try it again. Example 2 asks us that we find the prime factorization of 165. So let's bring in that list of prime numbers that we wrote on the previous page. Remember, whenever they give us an integer, a number that they want us to find the prime factorization, we're going to start by trying to see if it's able to divide by 2. If I do 165 divided by 2, I'm going to get a decimal. I'm going to get 82.5. So that means that I cannot start or use the 2. So we're going to have to move to the next number. In this case, is 3. We try to see if we can divide 165 by 3, and we can. 165 divided by 3 is 55. And then we try it again with the same number. We try to see if 55 can be divided by 3, and it can't. We actually get a repeating decimal. If you put this in the calculator, you get 18.333. So since we are no longer able to divide by 3, we move to the next prime. In this case, the next prime is going to be 5. So I try the 5, and 55 divided by 5 gives me an 11. And then since I get another prime as a result, that's when I stop, because my result when I divided by 5 gave me a prime number. So then the prime factorization of 165 is going to be these numbers that we have outside, the ones that we use to divide, the 3, the 5, and the last result. So 165 will be 3 times 5 times 11.
Thank you so much for watching, and I'll see you in the next one.